Hey guys, this is the video to go over the one activity that we're doing today. I am doing it for looking at my third block, but if you are in another class, if you're in one of my classes, they will all look the same. If you're in a different teacher's class, you just need to find your way to this activity, isotherms, analyzing changing temperatures. All right. And you already should have gone over the notes on changes in temperature and air masses before getting into this. And you will have a reading tonight, so just be aware of that and a little quiz. All right, so let's open this up. And I'm going to go ahead and make my own copy. So what we have here is isotherms, analyzing changing temperatures. We're going to go through and we're going to read a little bit. I'm going to make this a little bit bigger so you guys can see. So we're going to highlight what we think is important. So weather can be hard to study since the different parts that make weather are a part of a large system that you cannot see. One of the best ways to study weather is to look at variables such as temperature, pressure, and wind. In this lab, you will examine these variables on a map. So in this whole unit, it's all about analysis. And so the variables we're going to look at is temperature, pressure, and wind in this unit. So buckle up for that. Okay. Oh, I don't want that. Turn that off. How do I turn that off? Dang it. I don't know what just happened. Editing. Well, there it is. Sorry to waste your time with my inability to figure out what was going on. All over the country, meteorologists at weather stations collect data on the weather variables. This tends to be a large amount of information, but it can be analyzed in a simple way. We will connect points that have same temperature or pressure to better diagram what is happening weather-wise on that day. So you guys have all seen
classes in the 200 hallway are dismissed. Remaining classes at 2:35.
Images like this, we're like, oh yeah, obviously this is warmer, this is cooler. And the way that they do that is by connecting data given from weather stations that are all over the United States. Isotherms are lines of equal temperature. Let's highlight that. That's a huge vocab word. That are used to help us to identify both warm and cold air masses. The map to the right shows temperature measurements from around the United States. Meteorologists then analyze the temperature data to identify bands of temperatures within 10-degree intervals. Kind of a big deal. And draw isotherm lines on the map to represent each temperature band. In this lab, you will practice drawing isotherms and locating air masses on the map. Here are some rules for drawing isotherms on a surface temperature map. Isotherms are drawn in 10-degree Fahrenheit intervals. So each line is 10 more or 10 less than the one before. Always label the isotherm. You want to label it. Temperatures lower than the isotherm value are always on the one side of the isotherm, and higher temperatures are always on the other side. That might seem kind of confusing, but when we do it together, you're going to see and you're going to be like, oh yeah, that makes sense. Okay, so draw an isotherm until it reaches the end of the plotted data or closes off a loop. Neighboring isotherms tend to take similar paths, and then isotherms never cross. All right, if you're drawing one isotherm running into another one, you're wrong. All right, so looking at map A, so this is what it's talking about. Each one goes up by 10, right? This is 10, 20, 30, 40. When you look at this rule right here, where one side of the isotherm, you're going to have higher temperatures, one you're going to have lower. So if this is 10, 9 and 5 are going to be on one side of it, and then anything higher like 11, 13, 15, 18, 16 is going to be on the other side. So it's like if you could have a number line going from like 9 to 15, 10 is in between there. So you would draw your line cutting between there. Or I I sometimes think about it as like these lines are kind of like a lasso. So you have, if you're drawing the 20 line, you're going to say, all right, anything less than 20, I'm going to just draw a little loop around it. And then anything more than 20 is above there. Okay? All right, where are the coldest temperatures on the map? All right, look up a state map to guess which state this location is in. I'll do that for you. State map. Boom. All right, there we are. So the coldest temperatures, if I'm looking, are up here, kind of off to the side of Minnesota. So that would be North Dakota. North Dakota. North Dakota. Where the warmest temperatures on the map. So obviously that's going to be down here. So Florida and Texas. Florida is warmer than Texas. So Florida. Air masses are large regions of air with similar temperatures and moisture content. Study the isotherms and identify the cold air mass and the warm one. So we're going to double click here. Cold air is above. So I'm going to take my cold chunk of air and lay it right there. There's my cold air, just covered it up. And then my warm air kind of butts up against it below that. So right there, we haven't really talked about it yet, but what you're going to get is either a cold or a warm front. This looks like a cold front because it's whichever one is pushing into the other one. And right here, it looks like it's pushing into the warm air. Here, it looks like it's pushing into the warm air. And cold air, because it's denser, is typically stronger. If they're going to fight, cold air usually wins. Okay, so that's what that should look like. Now, let me zoom out a little bit. Use the rules to help you create an isotherm map of the surface temperatures shown below. The isotherms are already completed for you, so these are already drawn on. Believe me, in the past, we had kids actually have to draw these on, so you're welcome. All right. You may need to open the document in the Google Drive. Let's take a look. What do they mean by that? I don't know what that means. Oh, I think if you're struggling to be able to do this, you might have to like pop it out of Schoology. Okay, that's what that's saying. All right, so what you're doing is you're identifying what each line is. Obviously, right here is the 30 line, and if you look, it goes through the number 30 right there. Anything less than 30 is going to be on the inside. Anything more than 30 is on the outside. So this is going to snake around and say, oh, 26, you're less than 30. I'm going to go around you. 36, you're more than 30. And it's going to find another 30, cuts through. Anything less, 29 is on this side. 33 is on this side. And it weaves its way through, making sure that anything less than 30 is on the inside, anything more than 30 is on the outside. So let's go ahead and figure out what this line is. If we're looking, 23 is on the outside, 10 is on the inside. So what number is in between that? 20. So we're going to grab this number. Make sure when you pick it up, it has, see how my mouse has like 4 lines coming out of it? If you try and drag it without that, it will spread it out. It'll be weird. So anyway, the next one on the inside here, we have 0, but remember these go by 10, so this has to be 10. So we're going to grab the 10 down here, put it on that line. Oof, thought I was going to sneeze, and I didn't. It's terrible. Okay, here we go. All right. So we have our 10 line drawn, our 20 line drawn, and our 30 line drawn. Now we're going to go to the 40. So the next line up would be 40. That makes sense because the lines go by 10. And it follows our pattern that anything less than 40, like this 39, is going to be on the inside. Anything more than 40, like 42 over here, is going to be on the outside. We can follow that line. We're going to come out over here. So let's grab that other 40. The next line up would be 50. So let's grab the 50 line. And this is what meteorologists do. Well, actually, they have computers that do it now. But in the past, before they had computers, they would get these printouts of what everyone all over the United States. Oh no! Grab the wrong one. What their weather stations were saying, and then they would hand draw these lines on them and label them. All right, this is my 50 line. Anything less than 50, like 49 right here, is going to be on the inside. Anything more, like this 58, is going to be on the outside. So it cuts through the data like that. You then have 60 that we need to pick up. 60 is going to be the next line. You can double check yourself by looking. 61 is right there, and notice it's like right by the line, which makes sense because 60 is right near 61, except it's a little bit more than 60. So again, anything more than 60 is going to be on the outside. Anything less than 60 is going to be on the inside. All right, we follow this line. Boop, boop, boop. Bam. Right there. The 70 line is next. Because again, they go up by tens, at least temperature does. Temperature, isotherms. Notice that therm, like thermometer, has to do with temperature. So we look. Anything more than 70, like 71, 75, is going to be on the outside. Anything less, like 61, is going to be on the inside. Last ones are the 80s. All right. And you can see down in Florida, a little bit higher than 80 is 81. Anything less than 80 is going to be on the inside, like 75 right there. All right, save and close that once you got it. And then we're going to come to this next section where it says, what is the temperature range for our state on this day? The map above shows warm. Use both maps to answer the question before. Oh, okay. So this right here, I had to refresh myself. This map right here is like a color-coded version of this. Okay, might not look super familiar, but bam, there she is. So if I'm going to look at Pennsylvania, Pennsylvania's right here. We are right in this area. The temperature is around 54. Okay, so I would put, what is our temperature range? I'd put approximately 54 degrees Fahrenheit. All right, what are the coldest temperatures? So the coldest temperatures are going to be like 0 degrees. Oh, where are the coldest temperatures? Up there. I still have my map up, so that's going to be part of Canada and then Montana. Yeah, Montana. So where are the coldest? Montana and Canada. Canada. Where the warmest temperatures, as usual, Florida is killing it. It's in Florida. All right, so on the image above, draw in the direction of air movement for the central warm pocket as well as the cold pocket, okay? So if we double click on this, we're not going to change the colors at all. We are going to decide where's the Arctic, the polar, and the tropical air mass. Now, the tropical one is probably the easiest because, oh, hey, it's warm. Polar, remember, is cold air, so blue. Arctic is like super, super cold, okay? When trying to figure out where the front should go, especially because we haven't actually talked about this too much, obviously the red means that it's a warm front, and you want to put it, remember, where the warm air is kind of like pushing forward. because remember, the warm front, the actual front, that image right there is the front of the warm air. So this warm air is pushing up into this cold air. This cold air is pushing, let me pull that forward a little bit so you can see it. That cold air is pushing down into this warm air. All right, wherever there's these lumps, that's the warm air pushing into a different type of air mass, a different oh no, that wasn't what I wanted. Dang it. Come here. Delete. So I'm going to drag these in to where they're pushing in. That air is pushing in like this. This air is pushing down like this. So again, wherever there's these weird lumps, that's where one air mass is pushing into another. That's how I figured that out, okay? You're going to have to be able to figure that out too. All right, so now we're moving down to the last little part here. Again, we're looking at isotherms. Says where isotherms are close, the temperature changes. So here's isotherms being really, really close. All right. And if you were to drive across this state, you would notice that the temperature changes very quickly. So where the isotherms are bunched together, that means that it changes quickly in a short distance, showing a boundary between two air masses, or that's called a front. Which air mass do you think is stronger and why? Would cold air be stronger or would warm air be stronger? Because cold air is denser, it will typically win out and push into warmer air. Warm air is just going to be easily displaced, whereas cold air actually like rolls across the ground. So cold air is denser, so it isn't displaced very easily, displaced or moved. Okay. Drag and drop the correct air masses over the correct isotherms. Okay, so we're going to do that thing again where we take cold air. Boop, doop, doop, doo. Let's go like that. And then I'm guessing the warm air, they want that to be put in there too. Okay. After choosing the air mass that should be stronger, take the associated front and put it along the boundary line. So you might be like, well, why can't I use both of these? So we're looking at one air mass running into another air mass. Which one's going to be stronger? Because that's the one that is going to like lead the way. Remember, we want this to be on the front of the front. So if this one is being the aggressor and is moving into the warm air mass, we're going to have a cold front moving through the area. The cold air is going to win out. Does it always? No. You obviously have warm fronts sometimes. But for this image, we are going to have, or the cold air is going to win out, all right, and push into the warm air. And that's the front of that. Okay. What is the temperature and moisture profile of this cooler air mass? So, what is the standard abbreviation? Okay, so what this is asking, if you remember, up here we had like, oh, it's an Arctic air mass. Here it's a polar air mass. Here's the tropical air mass. Well, if this air is coming down and pushing into this warm air mass, it's obviously going to be cold. So it would be a polar, right? I think it's coming from the land. I think it's coming from Antarctica. So I'm going to say continental polar, or as we call it, CP. What is the temperature and moisture profile of the warm air mass? Okay. So the warm air mass is coming off of like the Florida area, which is the Gulf. So that's water. So that's going to be maritime. And then if it's warm, it's going to be coming from the tropics. So maritime tropical is going to be the abbreviation we use. Maritime tropical, or MT. Label the air masses with the standard abbreviation. Okay, so we're going to go in here, get this cold air mass. This is CP. And then this is MT. All right, let's save and close. And that is the activity. All right, you can go ahead and push submit after you're done. You did it.